Welcome. Today we're going to be covering the question, what is the integral of cos squared of 2x? One of the first things that we can note is cos squared of x can be written in two ways. We can say sine squared of x plus cos squared of x is equal to 1. And then we can say 1 minus sine squared of x is equal to cos squared of x. So we can say cos squared of x is equal to 1 minus sine squared of x. The second way that we can write cos squared of x is using something called double angle identities. And so when we look at the double angle identities, where else do we see cos squared of x? Well, we see cos squared of x over here, and we see cos squared of x over here. So out of the two that we've seen, which one would we lean towards to rewrite cos squared of x? Well, I see cos squared of x minus sine squared of x, but then that would have to mean that we would also have to integrate sine squared of x. But then I also see something that's way easier. We see 2 cos squared of x minus 1. So let's go with that. Cos 2x is equal to 2 cos squared of x minus 1. If we make cos squared the subject of the formula, then we say 2 cos squared of x is equal to cos 2 of x plus 1. And if we break that down further to make cos squared of x the subject of the formula, we would get cos 2 of x plus 1 divided by 2. We can also write this as half cos 2 of x plus 1. Now let me show you why this is important. If we were to integrate cos squared 2 of x, right? So I'm just taking an example of removing the x, right? Cos squared of x, if we were to integrate that, that would be so easy because then we just integrate the whole thing and we'd get half and then the integral of cos 2 of x plus the integral of 1. However, in this question we see cos squared 2 of x. And if we've chosen cos squared of x to be half cos 2 of x, then cos squared of 2 of x, which is just going to be 2 multiplied by x, we would then multiply this by 2 so that we can be able to match. Let me show you. So we'd say half times cos 2 of x times 2 plus 1. So that gives us half of cos 4 of x plus 1. So now we can see that we've written cos squared of 2 of x to be half of cos 4x plus 1. Because all we need to do now is rewrite the integral in this manner, saying half of cos 4 of x plus 1 d of x. And one of the things that we can notice whenever we integrate is taking out a constant to get us cos 4 of x plus 1 d of x. And then we can distribute the d of x respectively. That's perfect. And so now we have the integral of cos 4 of x, which would be 1 over 4 sine 4 of x plus the integral of 1, which would give us x, plus c. And that would be our final answer. Thanks for watching.